Heather's afraid of introducing me, so I'm doing it myself. Matthias, Racketeer. Okay, so this is going to be an interactive talk, at least at the beginning. And just to make sure you actually pay attention and you don't read your email, don't feed your social networking addictions, there's a prize to be won. Realm of Racket. Anybody know what it is? Realm of Racket is a book I finished a couple of years ago with 8 freshmen. I started with 25, but 8 survived. So at some point I will ask you a question, and the best answer will get this book. The person with the best answer will get this book, all right? So close your laptop, pay attention, otherwise you miss a decent talk. Let's go. So what's that? Anybody know? Just call it out. Dr. Racket. That's the IDE. We are known for that, right? Okay. What's that? That's an academic paper about Racket. So that's one thing, okay? What's that? Anybody know? What's the name of the game? Uncharted. It's a game produced by Naughty Dog, which is a studio of Sony. The budget for this game was $250 million. It's produced in Racket. Okay. So we live in 3 different worlds. We started out in the educational world, introducing students to good programming style. And there was a wonderful talk just a moment ago in the neighboring room about programming styles. We do research on this programming language, and we do research with this programming language, and industry has picked it up too. So we straddle all these lines, and we actually deliver on a regular schedule as if it were industry, but the core team is actually in academia. And this idea was pretty much a pipe dream for a long time for me. I didn't know how to make it real because this is a thought. At some point I had a eureka because Matthew walked into my office. Where's Matthew? Holy cow, it's not here. There we go. Without him, I wouldn't be here. So I just want to call out, I start my talk with an acknowledgement. It's him who made it possible, right? So what is this pipe dream? So what is this thing? There's this wonderful lie that Haskell is a purely lazy functional programming language. Everybody repeats it, everybody spreads this lie, and everybody just takes it with it. Yeah. We all know you actually program with monads. Monads are really imperative, but they lie really well, right? Python, same story. Wonderful lie. There's one obvious way to do it right. Krista just showed you there are 35 styles of doing it wrong. How about Racket? Is there a one-line lie for Racket? There isn't. I couldn't come up with one, so I'm going to give you 3 different ones. The first one is, it's a programming language. And there's a typo in there, it's missing a hyphen. Right? Okay. So that's not stuttering, I really mean that phrase. Next one, it's a full spectrum programming language because it is a programming language. And it is a linguist's language. Does anybody know what linguists do? Does anybody know what linguists think about thinking? What do you think about thinking? It's language. Well, who was that? It's all language. If you don't have language, then you can't get it. That was the question. Now you can go back to the social network feeding. Andy, good job. So linguists want to internalize every thought you have into language. If you can't say it in language, you can't think about it. So it's quite different from that first or the second one, right? And all of this lives in an intense feedback loop that we created from day one. We threw it out at the harshest possible audience you can throw an IDE at. K-12 students. If you think you have an IDE ready for an audience, try high school teachers. You're in for a treat. Okay, let's go through these 3 slogans. Programming language. Many, many years ago, somebody wrote a paper about 700 languages. You could make it 7,000 or 70,000 now. do we really need more than one? Because Racket per se is a programming language, right? Why more? Why do we need more languages, right? So imagine actually programming this game, this Uncharted game, right? These are the kind of problems you will encounter. You have to talk about physics. You have to talk about the scenes in the game, transitions between the scenes, the music, and many more things like that. What tools do we have as programmers to express that? We have for and while loops. Imagine that. We have methods and classes. And you might have a monad, and it comes for free. Those are the tools with which we tackle, with which we let people loose on really deep problems that have their own language. That's the state of affairs in programming languages. Stone Age. And the same is true for English. We don't really speak one English. Not even for native English speakers. I'm not one of them, but I've noticed that over many years. When you are in this game design world, some people talk about the story, some people talk about the physics engine, some people talk about music, but they have to get together. And Naughty Dog, by the way, follows that principle very much. That's why they don't think they're programmed, but the first thing they always write is left paren. And unlike you, they're not afraid of parentheses. All right? But you could also go into a boardroom, right? Everybody knows what a boardroom is for a company. You've been in a startup, maybe. And you know that the CEO talks CEO, right? And the CIO talks about, technology and operations, COO, and there's a legalese guy. They speak different languages, but they have a common substrate, English, right? So English is underneath these domain languages that they talk, and they figure out how to talk to each other with this common thing. But what happens when you do that? You use the word accounts in the financials part, you move it over into English, and it pops out at information. If you're out of luck, the account went from the money world into a Unix account. Right? So clearly it's not that simple to build these languages and put them together. But somehow we figured it out in English how to do that. It gets worse if you, So back up. Our dream is, we're not quite there, but we're on our way there. It's a research project, right? So the vision of Racket is that you build these languages and the common substrate is Racket. And of course, you all know that different styles of building DSLs, that embedded DSLs that have fluent interfaces to their host languages. We can do that. We have hard interfaces for little languages that are outside the thing. It works just fine. And the problem that we're tackling is, we want to build these things, okay, and want to glue them together. So there are two problems you see here, right? One, how do you build these DSLs so that things like the account word just means the right thing? But then how do you glue the programs together in these DSLs? Why do people build DSLs? Because each DSL has its own little conventions and invariants, as we call them, and stuff like that. And you want to preserve them at runtime in addition to having them done at compilation time. Okay. So let's tackle compilation first. You may know that I'm the one who coined that phrase, hygienic macros, decades ago. Okay. So it clearly must be all about that, right? Okay. And it actually is true. Remember this account thingy, you do this thing, you move it over, and it comes in here, and you plug in Unix. What you do is, when you build fluent interfaces between EDSLs and DSLs, you mesh together syntax from two places. And you better figure out how to preserve where the words came from so they mean the right thing, like account. Okay? Or account plugged into a phrase that came from somewhere else. Okay? So that clearly is something that we need to be able to do. But You can also imagine that this company has an external language, namely a European subsidiary. So here's a DSL for EU, if it still exists. Oh, sorry. And, of course, they want to ship something in a different language. It's a foreign language, an outside language, outside of Racket. It may not have parens. It has ugly syntax. So you need parsing, right? You need parsing to bring this language into your world where you build DSLs. Okay? That's clearly something else you want. You want to be able to enlarge the universe of languages that you deal with. High-chaining macros? Absolutely not. That's a very small piece of what we need. Building languages is much, much more than having the ability to throw one more macro at it. That's why I got up this morning and pushed back when David, I saw him somewhere here, had this strange remark that you don't want to use advanced language. In 50 years from now, you'll be alive, I won't. You will be using this kind of technology. So in Racket, you can literally write down modules in whatever language somebody's implemented for you. Of course, there's #lang Racket, which is the actual Racket language. There's a setup language for packages to find their way into the ecosystem. There's a documentation language for scribbling the manual that we have, or style files. We have style guides in there. There's #lang type Racket, our type custom, right? There's datalog, and datalog is datalog. You write down actual datalog syntax, and it runs. The only difference is you have to write this line. The first line in your module is this, okay? So to build that kind of thing, you need this whole stack of technologies that we've come up with over the last 20 years since I threw out 30 years, since I threw out high-chaining macros. I want to pick just one of those many, many features. Maybe I pick two. On what kind of thing you want to be able to do. This is all it takes to get you started on turning Racket into a lazy Racket. That's all there is. It's mind-boggling. And the key to that is the two keys. Number one, you need to understand that every application, every function application actually is a syntax node. Well, guess what? Everybody knew that. But you can reprogram it in our world. You can say, I want this thing, function applied to arguments, to be rewritten from here to there, where you have the suspension, this thunk sitting there. As a lambda thing. So it's not going to run, right? Well, what do you do then? What you do then is, on the way out of this module, when you provide things out of this module, you say, from now on, don't use regular application. Use that. Don't use @1. Use strict @1, the one that actually takes the argument and runs the func first. So the first line tells you we use every single feature. We inherit a complete language, a huge beast, and then we override certain features. It's just one example of what we do. We call this linguistic reuse, and this man, where's Shuram? Back there, he's now a pirate, has a whole dissertation on linguistic reuse. Okay, that's an example of what we're going to do. There's many, many, many technologies. Let me pick the last one. How do you get a foreign language with ugly syntax into the ecosystem, right? Of course, all you have to do is you write a parser with our parser tools, but you don't target normal ASTs. You just target the macro system, what we call the macro system, this whole stack of things. And everything comes along. The surface syntax attributes, the error reporting, nice checking of things, all this comes along. And you can report it back as if data log were a native element of your ecosystem. Okay? So I've shown you languages that are reasonably normal, full-fledged kind of general purpose programming language. Data log is not, but it's close. But you can imagine actually building, like Naughty Dog did, a language for the sound engineer, and a language for the scene composer, and a language for the physics guy. And they then start programming. They just don't call it programming. They call it describing their scenes, describing their music. And you compose them together into one game engine. But to compose them together, you write these actual programs in these DSLs, you glue them together, and you run them. Okay? And then actual values flow around from there to here, and we better make sense that when the COO talks to CFO, everything works out. Same for lazy. We just build a lazy language. If we don't take care of that func that goes into @1, things go wrong. So clearly, a value flowing from strict to lazy or from lazy to strict needs to have something with it. We have to be aware of these things, okay? So how do you deal with values as they go from one language program to another language program? That's the whole FFI problem over and over again. It's not. We lifted it up many layers in the trees. And you should think of these DSLs as a tree structure, and you only have to go down as far in the tree as you need to. I should have drawn a different picture, but that's the actual idea. So you don't deal with bytes, or you don't go through some kind of C-level interface. You go through the closest thing that matches. And how do you do that? Well, in the olden days, we used to say, good luck. Think positive, right? Hope. Don't do it. There was a lot of stuff going on. We've done better. We've improved. We have a lot of tools, just like on the syntactic side of building languages. We also have a whole bunch of things of building the runtime so these languages can talk to each other. I'll give you one example. One thing that you need to maintain invariance is contracts. Sophia this morning peppered Peter with questions about contracts. One of my former students, Claire, was actually moved into the closure world and started doing some of that stuff. How do you actually do contracts? Well, we don't have contracts baked into the language because you never know what exact shape you need. What you actually bake into the language is proxy values of the right kind. But exploring many different ways, we realized we needed two kinds of proxy values. And when we had them ready, we could use them for many different purposes. We call them impersonators and chaperones. So when you do that kind of thing inside a module that implements another language, you use actually these things, and you compile these contracts to these things. That's one example. There's a whole bunch of other things that we need to glue stuff together, like event spaces for GUI things, or custodians to keep track of resources, okay? And they come up again in a moment. So are all these DSL problems solved? Are all the compilation problems solved? Are all the runtime problems solved? Of course not. As I said, we are doing research. This is half vision, half done. But we have made huge amounts of progress, and that's pretty good. So when you realize that gluing together programs in different languages needs a whole bunch of mechanisms to preserve things as they go across these languages, right? You realize that you actually want much, much more than an untyped Lisp as modern as it can be. You want a lot more. So what we do is, and what we've done over the years, we've turned this upside down. We've turned it on the surface. We've turned this diagram on the sideways. What do I mean by that? We start with Racket, okay? But we really want a whole stack of programming languages. Fortunately, Racket is a programming language, so we can build that stack of languages. So one particular goal we had in mind is to build that stack. It turns out the stack is necessary to build the programming language part too. So it's mutually referential. But you know recursion works kind of. Okay, so how do we work that? So we have a Racket. On top of that, you may want to protect your APIs with contracts. Maybe you want to actually get them typed. Maybe you want them verified. The red stuff is not implemented. We're getting there. I'll show you an example in a moment. Or you want to go down the stack. Maybe you want to have an FFI so you can pull out a C library that counts word frequencies and have a one-line program to solve Krista's problem, right? Or maybe you want to drop down to assembly. It's not implemented yet. But you should dream of that you can drop down all the way to the bad stuff and do very unsafe things at the bottom if you need to. So how does that work? Full stack language is something where a normal Racket programmer starts with something like this. What you need to see is that there's an interface, an API, provide, and it's very nicely documented. The guy took my first course, knows how to do programming styles, no questions asked. And then there's a whole bunch of stuff, and there's more. And then you see yellow stuff. That's called defensive programming. It's not a bad idea. It's not the worst idea. Okay. But that's what we do in untyped languages. We protect ourselves, because otherwise it's our fault if something goes wrong. Okay. But then the guy who reads the API and doesn't want to read the whole module, that guy only sees this much. How can we bring this into the API? How can we assure ourselves automatically that these things work out just fine? That's what a contract is in a general sense. You lift out all this defensive programming into another DSL. This is, by the way, DSL, of course. Everything is a DSL in our world. A contract DSL just expands into regular Racket, elaborates down there. And you say, I get an object, it's an image. I get an X and a Y and a background, it's also an image. These guys clearly are numbers, so it says there. And they're in a certain range. Pardon the strange syntax for writing down ranges, don't worry about it. It's not important, you see the yellow. Dynamically check. Every time you call this, we check it out, and we figure out, hey, are you there? And if not, we synthesize wonderful error messages for you. Because, as I said at a public keynote many years ago, the slogan was, errors matter. When things go right, everybody's happy. When things go wrong, you want to have an automated, very reliable error reporting mechanism. That's what this is about. But you also see, oh, let me say, Robbie Findler is the guy who did that one, right? That's the guy up there on the right. You see this yellow stuff. Some of that should be a slightly different color. Because that really reminds you of a type. Right? So why not go to types? So we pulled out typed Racket. I want to be statically assured that these things are, the first thing is an image, the last thing is an image. Oh, there's a typo, there should be a range, sorry. We want static assurance. That's what a type system is about. Okay? We can do that. We can move from contract Racket to type Racket. Sam Tobin Hofstadt made that possible. Okay? Then you go like, hey, can't we do more? This is numeric stuff. We know how to do numeric stuff and numeric constraints. And that much we actually have. In addition to verifying the types, we can also validate some of the contracts with dependently typed Racket. It's going to be released anytime near you somewhere on a GitHub. These two guys are working on independent efforts in this direction. And there's even a fancier thing that says we're going to verify through the whole program all kinds of contracts. That's by David Van Horn at Maryland. So you can move up that stack as a programmer all the way. You can enter as a prototype man, and you end up at the top of the stack as a verified developer. Okay, we can go in the other direction. So Eli Barsile years ago put in a really cute FFI, and I didn't put the code in. It looks like Lisp. Wonderful syntax, beautiful syntax. Left paren, underline, dot, 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 right paren. Everything's parenthesized, but you're really programming in C. Okay? And it's all one homogeneous way of doing it. You don't have to switch worlds. You're in one world, in one ecosystem. So more of that is coming. If you are at Strange Loop, I recommend you buy a ticket for RacketCon. I'm not making any profit on that. And we have a cool speaker, Emina Tolak. She's coming here. I'm going to go over that with her for 2 minutes at the airport. But she is using Racket as another kind of DSL to program in a very different world, okay, in the SAT checking SMT world. So you write a Racket interpreter of whatever your favorite language is, but it actually spins off SMT and does cool stuff with that. Verifies programs all the way down. So things are taking off from here, and that is what Racket is as a full stack programming language. Racket is also a linguist's language. And Andy said, everything you think has to be in the language. Well, in our world, what we think is that you talk about money. Company guys talk about money, right? Down here. It's a resource. It's a common resource, and we all want it. So they're all grabbing it, except for one guy who wants to not let go. Okay. And what do you need to do that? What that means is that programs in DSLs go for common resources. You need to, they may be just time, it may be space, especially in a game setting, like a PlayStation where you have a limited amount of space. Space is definitely a resource. But it could be something like battery power, it could be all kinds of things, a printer, a connection to the TCP ports or whatever. Resources. And what we really mean then is, what we want to say is, if something is at the periphery of Racket, we need to bring it in. We need to have ways of talking about resources. That means, in principle, we are really a little operating system, or a little IDE, or all of it. Okay? So that's the actual full. I don't know whether anybody's ever seen that as Dr. Racket. Professionals use that environment too. When you open up all the tools, it's all the tools from about 5 years ago. There's probably more in there now. If you open up all the tools, you have a whole bunch of them, like module viewer, Modat. We have had this for about 15 years. There's all that stuff in there, right? Okay. And to get an IDE going, of course, we're functional programmers. So unlike Peter this morning, who said, well, of course we didn't apply infer and infer, we do build everything inside Racket. So the question becomes, and that's one of the elements we need to do to explore Racket as a real programming language, in our sense. What does it take to build everything inside? That's what I mean by linguist starts. And I'm not going to go into a lot of details. I don't want to do that, because it's very much in the fringe of things. But again, there's a whole bunch of things you can do. And it is so ingrained in our culture, going back to 95, that any conversation that I have with Robbie and Matthew ends up in, but how do I do that inside of Racket? Now, I will tell you, we cannot be ideologues about this, because some things really are better left to Unix. It does a few things right. Some things are left to device drivers. No. But a lot of things maybe should go in there. So this is a trade-off we're playing with for a long time. And that's what I'm going to leave it at. This is a product that came out in 95. We immediately threw it at high school students and high school teachers. Of course, it was a catastrophe. Catastrophes are incredible feedback. You go back and you fix it. And pretty soon, very quickly, we became an actual development team that also does research. But what I have realized as an academic, and this is where I differ with Peter, for example, what I realize is it is very good to be an actual developer if you want to be a good academic that's relevant. I'm not going to tell you that you're going to program in parentheses tomorrow. Maybe you are by switching to closure. But what I'm telling you is I want to have a vision how this translates into the real world. So we started from this very simple thing here. I went to students, and we have a little thing going back, going forth. And it is now all the way up to people who program big applications like games. This is the biggest application we know of. But there's small companies that have a dozen programmers, work for the DoD, or for the Air Force and things like this. And we really want all of you too. We want developers to try it out, see what it feels like. It won't fit in your stack necessarily, But maybe you get ideas on how to hack closure and use this advanced technology to get things right. Of course, what you will find that closure will break on you, but then you know how to build it. You just copy our stuff and port it to Racket, and they will be unbelievably happy, right? Okay. So what's the takeaway? I know I'm between you and the party, so I'll keep it really short. One slide. It's a programming language. It's a full stack language, and it's a linguist language. And if we as academics don't live in a feedback loop, we are doing pie in the sky stuff. So we don't. Thank you very much.
So I wanted to ask, you said that this is not supposed to be included in our current stack, but what are the efforts for that to happen? Because when we were having the discussion this morning on Clojure, what I get from Clojure spec is a list of tests, automated testing. I'm going to have a deployment system. I'm going to have, you know, all these tools that are required for the job. It's almost a religion these days. Yep. And when I go to Racket, I have Dr. Racket, which is awesome. I really like it. But it's not a good sell.
And there's Mike Sperber over here who put a quick check before it was in Clojure. And there are other things that you may not be able to find. So yes, maybe the tools are not as easy to find, but they're there. Are they as well developed as in Clojure? No. We are a community that's 10 times smaller than Clojure. But if all of you start programming in Racket tomorrow, especially you, then we'll have more tools in our world.
Carmack was doing it, was trying to push.
Matthew has the sign-up list where you can sign up for jobs. Well, they all want to go to the party, right? Nope. Well, in that case. Oh, I pushed on Peter too hard.
No, I love this because I love Lisp. So, I mean, you name-checked Landon's paper, Next 700 Programming Languages, earlier on, yep. Right? So is this sort of realizing that dream, or do you have a different, is it a different dream to Landon Reynolds around then, realized in scheme, I guess I can call it Racket a scheme, or is there a distinction in your dream?
Yes, there's a lot more. All that a Lisp can offer you at the moment is macros. Macros break. At a minimum, you have to have hygiene, but as I told you, it's one of 10 elements on just the syntactic side to make this dream work. So a plain Lisp system lacks expressiveness. When you mingle syntax from two different worlds, on the average, it's broken. That's true for Lisp, and it's true for Scheme. Okay?
So is that...
I build it for Scheme, so I know. So we're a derivative of those worlds. We have more, number one. Number two, Landon didn't have a dream. He had an observation. And you know that. The observation was you can separate the application layer, which to him, and Reynolds too, of course, was a bunch of libraries on, say, strings or numbers or whatever. And on top of that, there was a lambda calculus, including effects, by the way. He was never an ideologue like many have become. He had jump effects and side effects in there. And that's the essence of programming languages. If you lived today, he would add concurrency or parallelism to it. But that would be it. All languages have this structure. My dissertation picks that up. It says there's a three-dimensional space. Now I would say there's a four-dimensional space, and everything is generated from there, including objects and classes and whatever. That's a different dream. It's a dream of how do you analyze things. I did one kind of analysis. Morchi did another one and came up with monads, which were more easily translated into programming constructs. Okay?
Okay.
Don't be shy. Just tell me you want to go to the party.
You want to escape?
Of course.
Do you have any other stories of Racket in production apart from
Naughty Dog?
Well, I mean, that's a big one, yes. Other sort of.
Yes, and I can't talk about them.
Okay.
There's a bunch of them, and we know of about, I want to say, a dozen or so companies of small size that use it for various things. It goes from music composition to, I'll just say as much as I say this, like some software is deployed on battlefields. Okay. So it's, yeah. PLT scheme at some point used to live in every single Horizon switch, doing the error ticketing. So PLT scheme is the first name we had for Racket. Racket itself is 6 years old. The name is 6 years old, and we were first called PLT scheme, but we differ from scheme so much we gave it a new name. So when it was called PLT scheme, and I think maybe to this day even, it ran in every Verizon switch in the United States as an error ticketing processing tool. That was not a team, it was a single person who did that. It was supposed to be a year-long effort, and he was able to do it in our world in about 2 days. And Verizon was impressed and then deployed it in the actual switches. So error ticket is when a switch is basically a phone database. When a phone call comes in, it has to look up certain things about you and the recipient. So you get charged and you get connections and whatever. Usually something fails, not usually, often something fails. That's called an error ticket. Recovery comes on. You don't notice, hopefully you don't notice it in the phone call, but the phone company wants to know. The error ticket goes to an expert system. That's the Racket part. And then the expert system records something, debugs something, maybe even changes code or chips it back in. That's the idea. So that's an example. There's a public thing. Boeing is a subsidiary contractor for the Air Force in New Mexico and Hawaii. They actually had the first ad out about 15 years ago looking for a Racket programmer. They call it Dr. Racket programmer. And they control telescope batteries that officially look at stars, but sometimes for objects in certain near orbit spaces. That's another example. So if you want to live in Hawaii and program in Racket, there's still a position there from out here. That's about there are more stories. I don't want to go through a long list of little stories.
Does Racket have something for integration with databases?
Yes, but if you want to do data programming, go talk to him. Clojure is better at that. That's the story, you know. Yes, we have database interfaces, but there's really cool stuff over there.
Well, just to continue, so what would you recommend, like a first practical application if I want to introduce Racket, and probably wouldn't recommend to write a database server or web server in it, but
we have that.
What do you imagine is a good first practical use in a production setting? What would it be good for?
I mean, Naughty Dog found us like this. They had realized that everybody speaks exactly those domain-specific languages. They had written this in Lisp, in Common Lisp, and people realized that Lisp is a broken way of making languages. So the analogy is, if you have applications that need a lot of small domain-specific languages and you want to glue them together into something that runs on, say, like the PlayStation or just a normal desktop, maybe even a real computer. So the way they do it, not that much is public, they build these domain-specific languages, they compile them into something like Racket, and then it becomes a DLL that's linked into a small C++ engine, and they deploy that. So that's an example of where it would be absolutely great if you have many little dialects of things you want to do in your problem statement, then that's what you want to do. That's a big application. Small ones, what do you recommend, Matthew?
I think modest web services with a connection to a database is a common entry application.
Yeah.
Sometimes
we have one, but yeah.
Sometimes little GUIs on the desktop because we have a decent GUI library. When you don't want to be on the web browser for some reason, little domain-specific languages or little graphics things, maybe typesetting or documents, those kinds of things.
So sure, for example, bootstrap pirate with the #pirate, of course. You build a new programming language, you want to play with it. The very beginning of a programming language is a very intensive design feedback loop. And so the quickest way to get bootstrapped in a language is #lang pirate. #lang Andy's favorite language, you know, and you're up and running. You're up and running in a day. It's mind-boggling. And then you can explore your language, you find problems, and you fix it. And then you bootstrap. You want to say something?
I would, Matthew, maybe you have more updated version of this, but I would recommend looking up the Danny EU tutorial on how to do this.
Oh, yeah.
There's sort of there's a Racket way of doing this that makes it really quick and really easy. And how many of you have heard of brainfuck? Okay, good. There's a really great tutorial on how to implement brainfuck in Racket and how to improve its performance, use the performance, you know, because of course everyone needs high performance brainfuck. So there's a really good tutorial on that, except it was written by somebody who couldn't say the second half of that language name. So it's called how to fudge up a Racket. And that's a great tutorial on how to build a language inside Racket.
That's true.
Because it explains the philosophy of how to do it.
Thank you for reminding me of that. Yep. There's a question back there.
General question, you told about benefits, but what are the disadvantages? Do you see any problems?
Of course, it's a research language. A research language is not finished. We preserve backwards compatibility as much as possible. It's become a religion, a quasi-religion. Especially one of the developers steps on everybody's toes or everywhere else or somewhere back there if we are not backwards compatible. It goes as far as preserving bugs. It sounds crazy, but so that is the problem we discovered because people, it's like teachers, for example. We have about 100,000 downloads a year, and most of them are educational. And teachers have notes going back to 1990, whatever. And we break things for teachers they're worse than developers. They have their notes, they're yellow notes. I mean, as in yellowed paper, wilted, dried out, brittle to the touch, but that's where the notes are, and it has to work like that. We do that, but it's, of course, sometimes we have, that's why we are at version 6.6 now. Sometimes we do break these compatibilities and your host. We warned you early on, but your host. Number two, an academic team, as much as we can try to simulate industrial delivery, and we do, with regular release cycle, we were releasing in 2 weeks, we are 20-something people in the core. That's really 3 or 4 or 5 people, plus 20 more committers. Overall, there were 100 people committed. How fast are we in really fixing things when they break? Well, we're a small team. We don't have the resources. Sometimes we have to teach for a week or before we get to this thing. So that's number two. Our integration with the web stack is lagging. It's just a fact of life. It's not our thing. Many of you live on the web stack now, so you can't necessarily integrate it. So that's a disadvantage for the outside world. Many companies, many small companies, some big companies cope with that. As an academic, there are disadvantages. I think you're an academic, right? So if you're in academia working on a research language that's delivered and has to live up to industrial language standards, it's a hard thing to do. Peter talked about this morning. It's a 10x effort, and I actually agree with that. It's 10x over academic prototypes. When we write a paper, when Matthew, for example, writes a paper about the one I didn't make fun of it, but I said this is an academic paper about that stuff. He had the system up and running for a couple of years before he wrote the paper, because we go all the way to the end to deliver a completely, totally robust product. Robust means all the errors are done right. No academic will ever do that. Errors getting right, I give you one example. There's this famous lead macro that the lead hygienic macro from the 1980s or 70s. Guy Steele wrote it down, so it must be a saintly product, right? It sits there. It's 2 lines long in his little report. The actual implementation of this macro when we looked it up, it's 18 lines. 2 to 18, it's not quite, it's 9x, close enough for Peter's sake, right? It really is that much more of an effort to make it look like a native construct. Nowadays we have, so one of the dissertations I always saw recently was reduce that overhead because all these 16 lines can be generated automatically now. But before we got there, we had to write this to make, as an academic, make the software deliverable to industry. The Scala world is the same idea. Maybe not Heather, she's making a face at me, but some of the Scala people live in that boat where they have to deliver too. There are not many academic groups, if you look around, that can live up to the standard because it's so much more work. So I have only talked about disadvantages for an academic. So if you're a PhD student looking to find advisors, there's also a benefit. You are real. Nobody will ever doubt that you are real. Your stuff is used in mission-critical stuff. It's not fake prototypes that really don't do anything but give you one more bean on your CD, one more Pobble paper, one more ECOOP paper. No, it's real stuff that's out there. Does that answer the question?
Thanks. So for better or worse, C and C++ have become sort of the most portable languages around, right? I mean, if you invest into building a game engine, for instance, like C, you can compile it, you can run it on iOS, you can run it on Android, you can compile it to the web. Can you speak about portability and in the future, like making investment in Racket?
Naughty Dog is a fantastic example. 4 people work on the C++ layer, and the rest of the 800 people work on the Racket D layer. And that's a good ratio, because that way you keep these things portable to other platforms, and you have the actual expressibility in the language where you want it. Matthew has gone through many, many, many efforts to make this thing, make Racket portable. It's ported across many platforms. It runs on ARM, right? It runs on your standard platforms, and it's like Java. You write once and hope for the best for the others. I think we're actually better than Java probably, but who knows? So yes, it's very portable stuff. And so for example, the introductory course that I teach, students download it, they use various Linuxes, they use various Windows versions, they use Mac versions, and they deliver the homework, it's just fine. But we can tell the difference because the fonts are not quite right when they deliver the image or stuff like that. But it definitely is portable in that sense. Is it portable to so iOS, and I wouldn't say we're right there yet, but if you can clone Matthew, then it's going to be there tomorrow.
Okay, so I think we're actually at the end of the session, so let's thank the speaker, Matthias, one last time. And just as a reminder, there's a group of people that are going to be walking over to the party venue at 7:15. And everybody's meeting directly outside of the venue. So if you're interested in catching that group and all walking over together, meet outside then. Otherwise, check the ECOOP/Korean website, and there's a page for the party with the address and everything, so you can look it up on your phones or whatever. But hope to see you guys all at the party.
Heather's afraid of introducing me, so I'm doing it myself. Matthias, Racketeer. Okay, so this is going to be an interactive talk, at least at the beginning. And just to make sure you actually pay attention, you don't read your email, don't feed your social networking addictions, there's a prize to be won. Realm of Racket. Anybody know what it is? Realm of Racket is a book I finished a couple of years ago with 8 freshmen. I started with 25, but 8 survived. So at some point, I will ask you a question, and the best answer will get this book. The person with the best answer will get this book, all right? So close your laptop, pay attention, otherwise you miss a decent talk. Let's go. So what's that? Anybody know? Just call it out. Dr. Racket. Dr. Racket, that's the IDE. We are known for that, right? Okay, what's that? That's an academic paper about Racket. So, that's one thing, okay. What's that? Anybody know? What's the name of the game? Uncharted. It's a game produced by Naughty Dog, which is a studio of Sony. The budget for this game was $250 million. It's produced in Racket. Okay. So one of them, but I've noticed that over many years, when you are in this game design world, some people talk about the story, some people talk about the physics engine, some people talk about music, but they have to get together. And Naughty Dog, by the way, follows that principle very much. That's why they don't think they're programmed, but the first thing they always write is left paren. And unlike you, they're not afraid of parentheses. All right? But you could also go into a boardroom, right? Everybody knows what a boardroom is of a company. You've been in a startup, maybe. And you know that the CEO talks to CEO, right? And the CIO talks about, technology and operations, COO, and there's a legalese guy. They speak different languages, but they have a common substrate, English, right? So English is underneath these domain languages that they talk, and they figure out how to talk to each other with this common thing. But what happens when you do that? You use the word accounts in the financials part, you move it over into English, and it pops out at information. If you're out of luck, the account went from the money world into a Unix account, right? So clearly it's not that simple to build these languages and put them together. But somehow we figured it out in English how to do that. If you think you have an IDE ready for an audience, try high school teachers. You're in for a treat. Okay, let's go through these three slogans. Programming language, programming language. Many, many years ago, somebody wrote a paper about 700 languages. You could make it 7,000 or 70,000 now. Do we really need more than one? Because Racket per se is a programming language, right? Why more? Why do we need more languages, right? So imagine actually programming this game, this Uncharted game, right? These are the kind of problems you will encounter. You have to talk about physics. You have to talk about the scenes in the game, transitions between the scenes, the music, and many more things like that. What tools do we have as programmers to express that? We have for and while loops. Imagine that. We have methods and classes. And you might have a monad, and it comes for free. Those are the tools with which we tackle, with which we let people loose on really deep problems that have their own language. That's the state of affairs in programming languages. Stone Age. And the same is true for English. We don't really speak one English. Not even for native English speakers. I'm not Racket. Is there one line live for Racket? There isn't. I couldn't come up with one, so I'm going to give you three different ones. The first one is, it's a programming language, and there's a typo in there, it's missing a hyphen, right? Okay. So that's not stuttering, I really mean that phrase. Next one, it's a full spectrum programming language because it is a programming language. And it is a linguist's language. Does anybody know what linguists do? Does anybody know what linguists think about thinking? What do you think about thinking? It's language. Well, who was that? It's all language. If you don't have language, then you can't get it. That was the question. Now you can go back to the social network feeling. Andy, good job. So linguists want to internalize every thought you have into language. If you can't say it in language, you can't think about it. So it's quite different from that first or the second one, right? And all of this lives in an intense feedback loop that we created from day one. We threw it out at the harshest possible audience you can throw an IDE at. K-12 students. We live in 3 different worlds. We started out in the educational world, introducing students to good programming style. And there was a wonderful talk just a moment ago in the neighboring room about programming styles. We do research on this programming language, and we do research with this programming language, and industry has picked it up too. So we straddle all these lines, and we actually deliver on a regular schedule as if we were industry, but the core team is actually in academia. And this idea was pretty much a pipe dream for a long time for me. I didn't know how to make it real because this is a thought. At some point I had a eureka, because Matthew walked into my office. Where's Matthew? Holy cow, he's not here. There we go. Without him, I wouldn't be here. So I just want to call out, I start my talk with an acknowledgement. It's him who made it possible, right? So what is this pipe dream? So what is this thing? There's this wonderful lie that Haskell is a purely lazy functional programming language. Everybody repeats it, everybody spreads this lie, and everybody just takes it with it. Yeah. We all know you actually program with monads. Monads are really imperative, but they lie really well, right? Python, same story. Wonderful lie. There's one obvious way to do it right. Krista just showed you there are 35 styles of doing it wrong. How about